Very good morning to all of you. Uh, my paper topic is, the title is an adaptive method of PCA for minimization of classification error using Naïve based classifier. Uh, my name is Devesh Sharma. The first slide deals with the outline. That means what is the problem, what we are working on, what is the tackling, how we tackle that problem, what is PCA, what is Naïve-based classifier, and what is the proposed work. What is the problem with the work that is existing, and what is the proposed work, and what algorithm we have proposed for the problem, and not only proposing that particular algorithm to tackle the problem, but there is a comparison between conventional approach of PCA and the proposed approach. So the next part is comparative study and experimental result, and then conclusion and references. So what is the problem with the conventional approach of PCA? So first of all, we will deal with what is PCA. So PCA is a very classical technique which was developed in 1901, and it is mathematically proved. There is no drawback in its approach. It is a very efficient method for dimensional reduction of any data. Suppose we have very bulky data to work on, and we want to minimize the size of that particular data without minimizing or without losing the information associated with it. That means we will get the same amount of information, but the data size would be minimized, right? So it is basically a dimension reduction method. But what is problem with PCA, that somewhere, what references we have given, that somewhere we have taken traditional PCA, it sometimes mixes the data pixel that will further increase the classification error. So suppose we are using the PCA technique for any classification or any prediction or any recognition, whether it is face recognition, gender recognition, and anything. So sometimes in some cases it mixes the data pixel. The concept of minimization of approximation error in traditional PCA is get applicable in our work, right? So when the data points get extracted from the image, it should be hold their optimal position. That is the basic view, that will hold their optimal position, so that the better classification result will get occur. So what is basic problem, that it mixes data pixel, and when it mixes data pixel, the classification error or the classification error percentage will get increase, right? So the next slide is how we tackle that particular problem. How we tackle it? In this paper, we have commuted some concept in traditional approach of PCA. We have altered some concept a little bit, in a way that we have considered k minimum feature vector extracted from the image, right? I repeat, k minimum feature vector extracted from the image. So what we have done, basically we have chosen the feature vector projected along k minimum error, instead of considering k largest eigenvalue corresponding to the feature vector. Means instead of taking largest eigenvalue, we are taking the eigenvalue which is to the corresponding lowest classification error. Means the eigenvalue will be selected first, that would have the minimum classification error value, and that particular minimum error will be calculated using Naïve-based classifier, that we will show in the next slide or further slide. So the next, so that is the application of Naïve-based classifier in this particular work, that we are using Naïve-based classifier with traditional approach of PCA, not traditional approach actually, commuted approach of PCA. That means altered approach of PCA. We have altered some concept. We will see what is that commuted concept. Now the next slide is what principal component analysis is all about. That means PCA is a dimensional reduction procedure. We all know it. If we are familiar with data mining, fuzzy and artificial intelligence neural network, we will all familiar with PCA, what is principal component analysis. This will result into reduction of variables into smaller number of variables which are called principal components. So this is the definition of principal component, and which will account for the most of the variance in the observed variable, right? So PCA is a way of identifying pattern in the data. This is the basic application. The job of PCA are to do data compression, first of all, means minimizing the size of data without losing the, or without minimizing the information. That means we are getting the same information as we were got before. And then prediction part and redundancy removal. That means if some data is existing more than one times, it will get reduced when we apply PCA on certain data. So the bulky data will become very efficient and usable. Now feature extraction is the most important technique as far as my work is, or our work is concerned, because we have done the feature extraction part basically. So in traditional PCA, the larger eigenvalue comparing with the larger eigenvalues are chosen. The larger eigenvectors, comparing with the larger eigenvalue are chosen as principal components. So when we choose principal component and suppose this is the first principal component and this is the second, so this two principal component will be in orthogonal relationship with each other. So when the third one will be selected, it will be at orthogonal relationship with the second one principal component, and so on. So for n principal component. So this will make fluctuation in the data set. These are the principal components which are at the orthogonal relationship with each other. So this will definitely create a fluctuation in the data set. We will see that. So first of all, I want to discuss a little bit about name-based classifier. It is a very revolutionary technique developed in a neural network or artificial intelligence. So what it is basically, we have used name-based classifier for calculating the classification error once the classification error calculated. Once the classification error calculated, easily the vector can be projected by taking minimum error eigenvalue. I have discussed it earlier that we are using name-based classifier for calculating the classification error of particular eigenvalues of eigenvalues or feature vector that is projected along the k minimum classification error, right? So suppose we have chosen the first principal component along with minimum classification error, and then the second one, and then the nth one. So the covariance matrix now created is set along with the classification error from decreasing order to increasing order. So the principal component will first deal with the lowest eigenvalue with lowest classification error. Now a name-based classifier proceeds by assuming that absence or presence of peculiar feature of a class is distinct to the absence of any other feature, right? Relying on the explicit nature of the probability model, we can train name-based classifier. So the training and the learning part is there. We have to train the name-based classifier very proficiently in a supervised learning environment, right? Now the next slide will deal with the proposed work. Very important part of my work. In this part we will extract principal direction of covariance ellipse as done in PCA, but we will not blindly take the eigenvector corresponding to k largest value as a conventional approach of PCA did, but instead we transform the data vector into new n-dimensional vector space spanned by eigenvector and of the covariance matrix. Now what is covariance matrix is a question. So covariance matrix is a matrix in which there is a logical relationship establishment between different data exist in that particular matrix. So what we did, we have chosen the principal components corresponding to the minimum classification error first. Then the next one will be the next higher or the next larger value, then the previous one will selected at the second place, and then the third place, and so on. So this is the covariance matrix, in which there is a relationship establishment between the different signals existing in that particular matrix or data, right? So the covariance matrix of the input data, and then take one attribute at a time to perform classification. So one attribute selected at a one time with corresponding to the minimum classification error, and when the nth element has been taken, then now finally the covariance matrix is completed and will sorted out, right? Now proposed work is also deals with, we choose the attributes corresponding to k largest accuracy measures. That means this approach of eigenvector selection shall prove to be more effective than the traditional one, what we have proposed. With the improved approach to the conventional method, in which we have considered the feature vector corresponding to k minimum error in order to reduce the dimensionality of that particular data. So once the dimension has been reduced, now that particular bulky data is no more bulky to work with further, right? So these are the positive things with the proposed approach as compared to the traditional one. Now the proposed algorithm, what we have proposed and what we have commuted in the concept of traditional PCA. So we have written here iterative PCA minimum error algorithm, what we have given name to this particular algorithm. There is a data matrix, there is a covariance matrix which we have named a capital DM, and there is ET, that is for eigenvalue or eigenvector. So the first step deal with the calculation of covariance, that is DM. So we have to calculate the covariance matrix. So from the what traditional approach did, that maximum value eigenvector to the minimum one, but what we did is we have taken the eigenvalue with corresponding k minimum classification error, and so that we can diagonally put that feature vector, and then finally our covariance matrix is completed to deal further with. So the second step is perform PCA on DM. So what covariance matrix we have made, now perform PCA, or now apply PCA on that DM to obtain DMP. Means data matrix with the principal component part with the PCA scores. It stands for PCA scores arranged in ascending order. Of the most significant eigenvalue projected along k minimum classification error. So the third step, get the PCA score, principal component score, with the most significant eigenvalue. And what is that most significant eigenvalue in traditional approach? That is the eigenvalue corresponding to the largest, the eigenvector corresponding to the largest eigenvalue. But what is that significant value in our proposed algorithm? That is eigenvalue corresponding to the k minimum classification error. K minimum classification error with count being k, we have written. Now the fourth step is the mean of all normalized PCA score. Suppose we have lots of images we have worked on. Suppose we have worked on 45 images initially. So we have got the images with a uniform background from MIT CBL database or IIT Kanpur database. But suppose somewhere there is non-uniform background, or there is non-uniform images of person. So we need to normalize that all the images so that we could get the more efficient result, because we have to do the final illumination and the final uniform illumination or final uniform method to get the efficient score or result. Now the fifth step is, when the mean will tends to 0, the most significant eigenvector with respect to k minimum error, that we have discussed earlier as well, while dmi minimum error would be greater than dmi plus 1, that means m plus 1 minimum error. So what we are trying to say in fifth step, that what covariance matrix we have made, the first eigenvector will be established or will be selected according to the k minimum error, and the next one will be m plus 1, and next one will be m plus 1. So it is minimum, next one will be greater than this, and next one will be greater than this, and so on till the last PCA score will sort it out. Now the covariance matrix, the data records, that is DM, the data records corresponding to k minimum error PCA score. What we did DM with traditional approach of PCA was different thing, and what we are doing it with this approach is a different thing. If DM is not empty, so this step deals with if we are putting condition into it. If DM is not empty, repeat step 1 to 5 with the new DM and ET. If it is not empty, right? So ET is the eigenvector, right? Now the flow chart of the altered approach. What we are doing it, we have taken the original image training set. Then the second step is error calculation with Naïve classifier. We have discussed it earlier. Then we have applied PCA k minimum error, and we have got the eigenvalue and solved the covariance matrix finally. Then we have selected the eigenvalue with the lowest k minimum error till the last value has been sorted out. Now the comparison with the classical technique and advanced approach of PCA. This comparison has been shown in the previous paper of the author, which has already been published or recognized by Springer and IEEE. So this is the classical approach. We all know that the maximum eigenvalue taken along the maximum the eigenvector taken along the maximum eigenvalue, and the second is in conventional PCA we consider the vector projected along k largest eigenvalue. But the advanced approach of PCA, we have taken the eigenvector correspondent along the k minimum classification error first, right? But the altered approach has something else to take into consideration, and that is classification error. That's why we have termed our approach as advanced approach of PCA. In our method, we have considered the eigenvalue corresponding to k minimum error, right? This is the comparative study and experimental result. Kindly go through with it. And this is the conclusion part. Our work primarily all about is to minimize the network error rather than to recognize the face, right? With the improved approach to conventional method, in which we have considered the feature vector corresponding to the k minimum error, in order to reduce the dimensionality, we use the Naïve classifier further to calculate the error, and in order to achieve better accuracy comparatively, right? So these are the basic work we did, and the previous work was advanced approach of PCA with the kernel SBM, and what I did is advanced approach of PCA with the application of Naïve classifier. So the result is more accurate and more efficient than what we previous did, and these are the references. What I have worked with the author of my references, like Abhishek Kumarc. I worked with him. The previous work has already been published in IEEE and Springer, and this time it is for Elsevier, ScienceDirect. Thank you. Thanks a lot. Thanks a bunch. If there is any query, kindly send it to my mail. Thank you very much.